Hello, I'm Mr. Monty, and we're ready to start our lesson number 5 of the 2020 series. 20 lessons of 20 minutes a day for 20 days in preparation for the placement tests that are given here at the community colleges in Spokane. Lesson 5 is a continuation of domain and range. So, our I can statement is I can find the domain and range given a function. Well, yesterday we were given a function f of x is equal to. Today we're given a function in graphical terms, and we have to translate the graph by studying it. We're going to find the vertex, domain, and range, and then without the use of a calculator, we're going to see if we can determine what the f of x actually would look like in proper function notation. So let's get started. We're talking about a dish, a satellite dish, and if you have printed off your sheet and tried it, I'm going to mark a couple of important points on the graph. The y-intercept was 120, and at 200 we have 120, and then it actually touched the x-axis at 100, 0. Let's connect these points. So our shape is something like this. If you refer back to a couple of the other lessons, some important points that we always want to mark. The y-intercept. 0, 120 is our y-intercept. The 0, or where it actually crosses the x-axis, is at 100, 0. So, you have your worksheet. Translating it, we have two important points. Let's answer question A. What is the vertex? And they gave you 4 possible choices. The vertex is what we call the minimum or the maximum. This is a parabola. And it's in the form of a smiley face or a U. We also can call that a quadratic. Parabolas, quadratics, they have a minimum or a maximum. Since this one opens up, it has what we call a minimum. That minimum or the maximum is the vertex. So in this case, since it opened upwards, 100, 0 is the answer to the vertex. So we have several important points here, and if any of these don't hit home right away, make sure you make a note of them. Y-intercept, parabola, the shape, a quadratic, and the vertex. Alright, let's go on to domain and range. When we talk about the domain, we learned that we're interested in all the possible x's that are included in this function. Before we can answer that, in the previous lessons we talked about if we're given a function with no restrictions, they go on forever. In this case, that's not true. We have restrictions. This point and this point. Well, a satellite dish. It has a finite measurement. From here to here, and it's kind of bowl-shaped. So the possible x's would start here up to here. This particular function only exists from 0 to 200. The possible x's that we can put into the function. So let's write that, and we'll use it in sentence form. X's exist from 0 to 200. in math notation, we could actually say 0 less than or equal to x less than or equal to 200. And we say the equal to because it is at 0, 120, and at 200, comma, 120. So those are included in the domain. Now let's look at the range. The range is all the possible y values that can come out of the x's. Remember, x's are the input, then we have the operation, then we have the outputs, or the y values. Well, if these are the only x's we can put in, then we can look and see the only y's that come out. From here up to here are the y values that are possible. Well, what are those? From 0 up to 120. Let's put it in sentence form. Y's exist from 0 to 120. In proper math notation, we can say 0 less than or equal to y, the y values, which are less than or equal to 120. So now we've answered the domain and range. The final part of this problem actually stated, without a calculator, choose which one of these functions could represent the satellite dish. Well, the reason I want to focus without a calculator is because I want to make sure that everybody, when they see these different notations, function notation, it makes sense to them. One of the most important things in graphing is the y-intercept. The y-intercept. I'm going to actually circle that. Y-intercept. Whenever we have an equation, the y-intercept is when we put in a 0 for x. So x equals 0. Well, let's look at these and say, when x is 0, what is the y-intercept? 120. That works. X is 0. Well, we get a 120. That works. X is 0, 120. X is 0, 120. Unfortunately, the y-intercept is correct in all of them, so that didn't help us. Okay, let's look at the next thing. When we see an equation, y equals 1.2x plus 120, let's try to think back a couple lessons. What type of a shape does that equation give us? We have a single variable. It's not raised to a power. Do you remember this? Y equals ax plus b. B was the y-intercept. A was the slope. That's right, linear. Linear. So we have a slope. So these two are linear. Well, that means they're a straight line. We don't have a straight line. So it can't be either one of these. So let's just get rid of those. No, no. Now, without the use of a calculator, this is a little more difficult. We have an x squared. Ooh, x squared. That, a parabola or a quadratic, and an x squared. And we got some strange factors in the middle here, minus 2.4x. We're not sure what that does. We like our 120. So it could be either one of these. Let's try to think back in our family of functions when we were doing those in class last fall. Family of functions. What does the minus do? When there's a minus in front of a quadratic, you've got to try to remember what that did. X squared made a shape of a smiley face. But when we changed it to a minus x squared, it reflected it across the x-axis or made it open down into a frowny face. Minus x squared. So minus x squared would open this down. So it can't be that one. We'll put an x through that. I hope you can see that even if we don't have a calculator, many times we could actually go through and solve and find the answer. I'm going to put a star right by the third choice here, because this is the one we want, the smiley face right here. This is our answer. Just in case that still wasn't enough information, remember how we built our 3-column data table, X, operation, and then the outputs, the Y values. We could actually do that to get more specific and see if we can pick from that way. All right? That actually wraps up lesson 5, an actual context problem with domain and range. So let's remember now, I can find the domain and range given a function. The twist today was our function was given to us in graphical form rather than equation form. So we came at it from a different angle, but we were still able to solve the problem. That wraps up lesson 5. See you next time for lesson 6.